Hey, grade sevens. This is Maths Evan, lesson 8.7, graphing rotations. It's the last lesson in our textbook. What we're going to be doing, this is the third type of moving a shape or some points around on a graph. It's rotations. First, we had translations, which is simply just taking a shape and moving it somewhere, not rotating it or anything. Then we had reflections, where it would flip over maybe an axis or a line one way or the other. Rotations is now a spinning around a certain point. So a way to imagine it is, imagine this point is connected by like a string and we spin around. Or maybe we could use a compass and line it up, and we're going to spin it around 90 degrees, for example. Let's spin it 90 degrees. And there's this point that it could end up. Okay, so I rotated this point 90 degrees. Okay. If I were to take my protractor and measure this angle right here, it would be a 90-degree angle. Okay. If I kept going with this, I could get a different degree, maybe all the way around to this opposite quadrant. Could be 180 degrees, right? So that was 90 degrees all the way around to the opposite side, so that this was straight. This would be a 180-degree angle. We could go even further and go all the way over here. We could get to 270-degree angle. Or we could go all the way around and it would be a 360-degree rotation, which is why when you jump around in a circle perfectly, they call it a 360. So to this point right here would be a 270-degree rotation. Would be to that point, and then 360 is all the way around. Okay. All right, there's something you should know. A rotation is considered positive. So if it says to go positive 90 degrees, it would be counterclockwise. So you'd go from the point, and around this point, you'd go counterclockwise. So, you know, on a clock with the hands, clockwise is this way. Well, counterclockwise is the opposite. It's counter to it. It's opposite of it. So clockwise, though, going the opposite of these ones, so going this way around, would be a negative rotation. So clockwise is negative. And the reason, or the way that I remember this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. From going from quadrant 1 to 2, if you were to rotate around from quadrant 1 to 2, that would be a positive rotation, because 1 goes to 2, it added and became 2, right? It became more, it became more, and it became more. So that's how I remember whether counterclockwise is positive or negative. Going from quadrant 1 to 2 to 3 to 4 is positive, okay? And going the opposite, getting less, would be the negative rotation. Now, to notice something, a 90-degree rotation positively would end up here, and a 270 negative rotation, so negative 270 degrees, would actually bring us to that same spot. So a positive and a negative would end up at the same spot if their values, absolute values, so the positives of their values, were added together, would equal 360. I highly recommend you to read page 325 to 327, the examples, and try to follow along, because there are a few different things in there that I might not touch upon fully that I think will help. But we're going to do a couple examples, because I think doing examples is the best way to figure this out. All right, here's an example. It says A plot points G 24, H 31, and I 22 on the graph. So that just means put them on the graph. So G is going to be 2, 4, 2 to the right, 1, 2, and 1, 2, 3, 4. That would be point G. H is 3 and 1. So 1, 2, 3, and 1. And I is 2, 2. So 1, 2. 1, 2. Then it says connect the points to make a triangle. So you just take your ruler and line it up. Okay, so you've got this triangle, GHI. And now it says rotate negative 90 degrees about the origin. So right now we're in quadrant 1. A positive rotation would take us to quadrant 2, quadrant 3, quadrant 4, back to quadrant 1, and you could keep going. So we know that negative is the opposite, right? We need to go the opposite way, which means that we're going to end up here in quadrant 2. Okay? Now I'm going to show you a couple different ways to look at this. What I remember doing is I'm rotating this way. So what I can do is take my paper and actually just flip it like this. And if I flip it 90 degrees, so just turning it so that left is down, down is right, so forth, right is up, and up becomes left. This shape that was here should be the same as the shape here. So if I think about it, I'm just going to write this down so we can find some patterns. G24, H31, I22. For G prime, I'm taking this, and you notice that it's got 2. It's 2 away from this line. I'm now going to make it 2 away from this line. Okay? It's going to be 2 away. It's going to be somewhere along here. And it was 4 up from this line. So it's got to be 4 up from this line. So it's going to be 4 up. So it has to be right here, which means it is at positive 4 and negative 2. Okay, just follow along. We'll get there. What about H prime? It was 1 away from this line. We need to now rotate 90 degrees. It'll be 1 away from this line, right? It'll be 1 away. And it was 3 away from this up line. So it's got to be 3 away from this line. Okay, so it's got to be 3 away and 1 away, which would mean that it would be right here. So this is G prime, this is H prime. And here we had 2 away and 2 away, so we need to put it at 2 away and 2 away. It's going to be right there for I prime. And when we connect this, we end up with a triangle that is the same shape. It's just been rotated around the origin. Now let's look at this. H is now at 1 and negative 3. H prime. I prime is at positive 2 and negative 1. I meant to say 2, negative 2, right? It's negative 2. And just to check this, you'll notice that here, G to G prime, if you make that triangle G, O, G prime, if we line up our ruler, it's like a corner of a ruler, a corner of a piece of paper. It is a 90-degree angle. In fact, from I to the origin, so let's draw a dotted line here, to origin to I prime, it is also a right angle. It's like the corners, right? That is also a right angle. Okay, and as well, H to the origin to H prime is also a right angle. Okay, they are all right angles because a right angle is 90 degrees. We went negative 90 degrees. It's still a right angle. It's just moved around the other way. Another way to kind of check that we've done this correctly is to take our compass, put it on H, and if we rotate around, it should go through H prime. Does it go through H prime? Yes, it does. Or take G, and does it go through G prime? Absolutely it does. Or find I. Find I. Does I go through I prime? If any of these don't, that means it's not a rotation. There would be some sort of translation in there or something. There was a mistake made. You'll see that I and I prime connect, okay? So when it's a rotation around a point, your I and your I prime must be the same distance from that point, and they must be on that rotation. Your G and your G prime have to be along it, and your H and H prime have to be. That's what a rotation is. I want to point out another thing here. When you rotate 90 degrees positive or negative, either your X or your Y coordinates will become the other coordinates. So notice that the Y coordinates here, 4, 1, and 2, became the 4, 1, and 2 in the X. So the Y's became the X. And the X's became the Y's, but just flipped their sign. 2 became -2, 3 became -3, and 2 became -2. This will always be the case for the rotations, that the numbers you're dealing with will be the same numbers. The signs will just switch. So that leads me to kind of a quicker shorter way to do this. And we're going to now just add a little question here, D. We're going to rotate a different amount. Okay, we're going to do 180 degrees and we're going to label it this, but we're actually going to do this without drawing it. We're going to do these coordinates first and then draw it. I'm also going to erase all these extra little things in here just to make it a little neater. Let's just remember that in quadrant 1, all of your coordinates will be positive, right? It's only positive for the Y, it's only positive for the X. Here in quadrant 2, you will always have, X will be what? Negatives, right? They're negative numbers. Y's will be always positive. In quadrant 3, they're both negative, right? Negative Y's and negative X's. Negative X, negative Y, always. And over here in quadrant 4, we will always have a positive X but negative Y. Positive X, negative Y. I'm just going to move this out of the way a bit. So Q3 is negative and negative. Okay. So for this thing here, this rotation, I'm going to write these in again, what my G, H, and I are. Just going to copy these down. Okay. And all I'm going to do is do one of these the way we did it before and just see what happens. I'm going to take this H, for example. I'm going to bring H around, all the way around here. I'm going to end up right there. Okay. What was up 1 is now going to be down 1. What was right 3 is now left 3. This is my H double prime. Okay. I'm going to explain this in a moment. It becomes -3, -1. Okay, notice for a rotation that's 180 degrees, you just flip your signs. Okay, what about G? If we flip our signs, we're going to expect that it's going to be -2, -4. -2, -4. So let's go -2, 1, 2, and go 1, 2, 3, 4. There is my G double prime. And I double prime is going to be -2, -2. Let's go -2, -2. There is my I double prime. And then we connect this triangle and it'll look like the other two just spun around. Notice that this long edge is further away from the origin than the other two. This long edge is further away from the origin than those two, and this long edge is as well. That's kind of a way to check it. But this was a 180 degree rotation. We're going to notice something here. When it's a 90 degree rotation, you flip your X and Y, and then you just look and see, okay, is X supposed to be positive or Y in that coordinate? Okay. So looking here, if we're going to do a 90 degree rotation now, let's do positive 90 rotation. Let's call this E. So we're going to do a positive 90 rotation. about origin, right? And we're going to call it triangle G triple prime, H triple prime, and I triple prime. Let's try to figure out what these points will be. Well, it's a 90-degree rotation difference from here. So we're going to just flip what the coordinates are. We're going to flip our X and our Y's. So G triple prime is going to be the opposite of this. It's going to be 4, 2 instead. Our H is going to be flipped opposites. It's going to be 1 and 3. And our I triple prime is going to be 2 and 2. Okay? But then we need to figure out our negatives and positives. Think about this coordinate. What's negative, what's positive? X is always negative, Y is always positive. So let's go here. It's going to be -4, -1, -2, and then positives, okay? So let's put these on here. G -4, +2. So G prime, prime, prime is -4, +2. Let's go 1, 2, 3, 4. +2, it would go right there. That is G triple prime. Okay, what is H? H is -1, 3, -1, 3. Triple prime. And I is -2, 1, 1, 2, 1, 2. I said -2, 1 again. I meant to say -2, 2. And there we go. That is our shape. And we'll notice that it's that same thing. Any points on here that have the same letter, if you were to take a compass and put it to one of them and rotate around, they'd all be on the same circle. They'd be the same distance from the origin, and they'd be the same distance from their counterparts as each other to their counterparts. Okay, so I'm just going to write down a few things here. Sorry guys, I didn't realize my camera got rotated a bit there, or maybe the paper did. Let's write down some conclusions. So for 90-degree rotations, we take our X and our Y values and we just flip them, okay? So for example, let's do C as a point is 3 and 2. Okay, 3, 2. It's going to become C. We're just going to flip these two, okay? So it's going to be 2, 3. We're not done yet. And then we're going to compare with the quadrants. Let's say it's going from quadrant, well, C is 3, 2, so that's quadrant 1. And let's say we're going to that's quadrant 1, and we're going to quadrant 2. So quadrant 2 would be from here, there's a shape in here to shape in there. Okay, quadrant 2 we know is always negative positive. So this C prime, almost C prime, it's not there yet, would have 2 and 3. So we're going to bring this down. It's 2 and 3. But now remember, quadrant 2 has negative first and then positive. So it's -2, -3. And that's what C prime would be when rotating 90 degrees. Okay? Remember, quadrant 1 is always positive, positive. Quadrant 2 is always negative, positive. 3 is negative, negative. And 4 is positive, negative. So first flip the values, then compare and put the correct signs. 180-degree rotations. Okay, if it's 180-degree rotations, it's simply this. Flip X and Y. And 2, flip signs. Okay, so let's say we have D. Let's do point D. Let's say we have D 4, 5. Okay, we're going to flip X and Y. We're going to make it D prime. Not quite there yet. Okay, D prime will be 5 and 4. Anyone notice a mistake I made? I got ahead of myself. Yeah, we do not flip X and Y. We simply flip the signs. That's all we do. That's all we do. If it's positive, it becomes negative. If it's positive, it becomes negative. If it's negative, it becomes positive. We just flip the signs. So D prime, for a 180-degree rotation would be just flipping the signs. Sorry for the mistake there. Okay, so 90 degree, flip X and Y values, and then compare with quadrants and put them. And then 180 degrees, you simply just flip the signs. You just flip negative to positive, positive to negative.